This is the seventh section of chapter 8 on critical path analysis, and this is on resource histograms. Now, so far in critical path analysis, we've looked at activities, but we haven't looked at the number of people or workers that are required to complete that activity. This is where a resource histogram is useful. It's a way of displaying the number of workers needed for a particular activity. So this is what a resource histogram does, but there are one or two rules to do with the workers. So these points are this: a worker can only be assigned to one activity at a time, so they're not allowed to multitask. They must only be assigned to one activity. Once a worker has started activity, then they must finish it. They've got to see it through to the end. They can't be taken off that activity and assigned to a different one. And when a worker has finished an activity, they immediately become available to start a different activity. And lastly, with resource histograms, we've got an activity or a process called leveling. And leveling is the process of adjusting the start-finish time of activities for those activities that can have their start and finish time changed to take into account any constraints and resources. For example, it may be that an activity now requires 3 workers instead of 2, or it may be that an activity is delayed in its start time. So what does a resource histogram look like? Well, it actually looks like a histogram. Up the side we have the number of workers on that scale. On this scale here we have like the number of days or hours or weeks or months or even years. And then the height of the bar is going to represent the number of workers that are needed in a particular time. So for example, if this were days here, then we can see for the first 2 days, and if this was like, I don't know, going up in 5s, 5, 10, we would need 10 workers. Then for the next 3 days, we only need 5 workers, and so on. Example 13. Here is the Gantt chart from question 2 of exercise HE. So it's here, it's done for us. The number of workers required for each activity is shown in this table here. Draw a resource histogram to show the number of workers required each day when each activity begins at its earliest time. Okay, so the first thing I'm going to do is to write the number of workers here in each of the bars here, activities, to help me keep track of what I'm doing. So A was 2 workers, B is 1, C is 1, D is 2, E is 1, F is also 1, G is 2, and H is 1. So now I'm going to draw my axes. So I start by drawing the vertical axis and labeling it as workers. Now I need to know how far to go up. If I sort of go down at any one time, I can see the maximum number of workers. So I can see at this point in time I'm going to need 5 workers. Here is going to be 4, so I'm not going to need any more than 5 workers at any one time. So that's going to be the highest point of my histogram. So I only need to go up to 5. And I can see that I need to go all the way up to 26 on my horizontal axis, and that is going to be the number of days. So when we draw a resource histogram, we always start with the critical activities, this critical path here, and this is going to go along the bottom of our resource histogram. So we'll start with activity A. So activity A requires 2 workers, and it goes up to 7, the beginning of day 8 actually, or the end of day 7. So my bar is going to look like this. It's going to have a height of 2, and it's going to go all the way across to 7 and stop there like this. And I'm just going to put the letter A in it for now. Then activity C goes from 7 to 11, only 1 worker, so it's only going to be 1 unit high. So 7 to 11. So that finishes here. I'll put a C in that. Then activity F, 1 worker, goes up to day 18. So activity F goes up to here, and then activity H goes right up to day 26 or the end of day 25, and that's just one worker. So that is going to go up to the end here, and we'll put H in it. Okay, so we've done these activities here. So always complete your critical path first. Those or critical activities, those are going to go at the bottom. So next we move on to activity B. So activity B is just one worker going up to 3. So one worker here up to here, and we'll label that as B. Now when we move on to activity D, that requires 2 workers, that goes across to 9. Now when we fill it in, we don't just like plonk it on top of here and have a bar, something like that. What we need to do is that when it gets to this point, we need to draw the rest of it down here. We need to slide it down. I'll show you what I mean. So activity D starts when B finishes, which is on 3, like this, 2 workers, and it goes across to 9. So I can go across here like that, and then it's going to drop down 1 square up to 9. So the rest is going to look like this. Okay, so this would be D. Okay, so see how when we get to this point here, 7, we just drop it down so it fills that gap. It's a bit like Tetris, I suppose. You want to make sure all the gaps are filled. So if it helps, you could draw like a dotted line to see how this last bit here has just dropped down to fill that gap. Now we move on to activity E. This starts at the same time that D starts. It's going to start here, and it goes all the way across to 13. So we're going to do a similar sort of thing. So one worker up to this point. Maybe I'll just do a dotted line to say that it's going to drop. So maybe I'll put that as a D there. So this is still E here. This is still E. And then when it gets to this point, it needs to drop down because we need to go all the way across to 13. So we'll go up to this point here, like that, and that's the rest of E. So it still represents the same thing, but it's dropping to fill the gaps, as I said, like a Tetris game. Then lastly, activity G, that requires 2 workers, and that's going to start at 9. So it's going to start here. So we need to show 2 workers on top, like this. And activity G needs to go all the way across to 14. So when it gets to here, it needs to drop down and just fill up this gap here. So I'll just label that as G. So there's my completed resource histogram. What I might do is just draw an outline here around the edge of the resource histogram, so I don't have those dotted lines there. Example 14. The diagram shows a project model by an activity network. The number on each arc gives the time in days required to complete each activity. The number of workers needed for each activity is shown in the table. Okay, so number of workers needed is here. The activity network is shown here. A project manager determines that each activity should start at the earliest possible time. Okay. Part A, draw a resource histogram to show the number of workers required on each day and state the total number of workers needed in this situation. Okay. So we'll start with our axis. Now I don't know what the total number of workers is going to be, so I'll just draw a scale that goes up here like this, and I can fill in the numbers in a moment, but I do know it's going to take 21 days, so I know how far to go on my horizontal axis. So first of all, we need to identify the critical activities so that we put those in first. So let's start by looking at what the critical events are. So where the numbers are the same here, and then we'll just check that the maths works for those numbers. So I can see that A is a critical activity, 16 plus 7 is 13, that's a critical activity, and 13 plus 8 is 21, so H is a critical activity. So these are going to be the ones that I'm going to fill in first. So starting with activity A, has a duration of 6 and requires 1 worker. So we'll do that. So 1 worker here. So I'll basically have each square for 1. So that's activity A. So we'll just tick it off as we do it. Activity E. So we won't just go straight down the critical activities first. So activity E has a duration of 7 and that requires 1 worker. So activity E has a duration of 7 and we can see exactly where it finishes. It's going to finish at 13 and that's 1 worker. So these should be the easy ones to fill in. So we'll tick that one off and then we'll go to activity H, which has a duration of 8 that finishes at 21 and H also requires 1 worker. So that's taken us right to the end of the project here and we'll put H and we'll tick that one off. Right, and then we sort of start from the beginning again and work our way to the end. So we'll look at activity B. That has to start right at the start here. It does have a slack of 1, so it could be started at 1 and still finish at the right time, but it says that each activity should start at the earliest possible time. The earliest possible time for B is 0 and B requires 2 workers. So we want to go from 0 to 3 with 2 workers. So 0 up to 3. There's B. We'll tick that off, 2 workers. Right, now what we're looking for now is activities that we can start at 3 because we don't want to really leave gaps. I mean, I don't really want to go on to C, have a gap, put C in and then try and slot things in. So what activities can start at 3 as early as possible? Well, both F and G, their earliest start time is 3, so I could put F or G in. So I'll put F in first. F requires 1 worker and it has a duration of 9. And if I do 3 plus 9, I get 12, so it's going to finish at 12. So be careful, don't look at that number there. It's actually going to finish earlier than that. It's going to finish at 12. So F1 worker, slot that in there, finishing at 12, so put F in there and we'll tick that off. And then we said also G can start at 3, that has a duration of 8, so we'll need to do 3 plus 8, so it's going to finish at 11 and that needs 2 workers. Right, so that's going to be 2 workers here and this one's going to finish at 11. So I'll go all the correct way to here, finish that off and put G in that box. So now that just leaves activities C and D. So let's start with activity C. The earliest it can start is 6. That requires 2 workers. So if it's going to start at 6, it's going to start here. And the duration is 8. So that means it needs to finish at 14. So I'm going to have to slot things down up to 14. So it might be helpful just at 14 just to put 2 workers there because I know where it's going to finish. So I'll draw my line here for C. Then it's going to drop down and fill this space here. It's also part of C, and then it's then going to drop down and fill that space there. So that's also part of C. So I'll just put a full outline on that now. Once I've worked out where it needs to go, and I can probably rub out these dotted lines here. And we'll tick that off, and then the last activity is going to be activity D. The earliest that can start is 14, so it's basically going to start here, and that has a duration of 4, which means it's going to finish at 18. So we'll just put that in, and D requires just 1 worker. So that's up to 18 there. That's activity D. Okay, so our resource histogram is complete. We'll just put the number of workers here because we can now answer the other part of part A, which was to state the total number of workers needed in this situation. And you can see the histogram peaks at 6, so we'll just put 6 workers are needed. Right, let's move on to part B. Now it says here, due to budget cuts, only 4 workers are available for the project. We saw that we needed 6. There's only going to be 4 available. So that means that the height of our histogram can only go up to here. So we're going to have to do something about this in a minute. Use resource leveling to show that the project can be completed with just 4 workers and state the total time required to complete the project in this case. So it may mean that we have to extend the finish time of the project to enable this to be done with just 4 workers. So resource leveling is all about looking at where we can move the start and finish time of any of these activities to allow the project to be leveled off at 4 workers. So what we need to do is to look at the activities and see which activities have floats and how much that float is. So the first activity that I can see that has a float here is B. 4 minus 3 minus 0 is 1. Okay, so B has a float of 1. And because of the finish times here, it can be delayed by 1 day. Delayed by 1 day. Activity C, which is here, that also has a float. So that has a float of 17 minus 8, which is 9, minus 6, which is 3. And so its finish time can be delayed by up to 3 days. So C can be delayed by 3 days. What other activities have a float? It's not going to be the critical activities. So let's just go for an order. D, we'll work out the float for D. 21 minus 4, which is 17, minus 14. That's also got a float of 3. So activity D, that can be delayed by 3 days. Delayed by 3 days. In the other activities we have, so E, F. Let's have a look at F. So that has a float of 13 minus 9, which is 4, minus 3 is 1, so it's got a float of 1. So we can delay that by 1 day. And then the last activity that's got any sort of float is going to be G. And G is going to be 13 minus 8, which is 4 minus, which is 5. 5 minus 3 is 2, so G's got a float of 2, so we can delay by 2 days. Now if we look back at the diagram, this is the hump, the peak we want to get rid of. We really want to move this over here somewhere. And we want to look at the activities that have the largest floats. That will have the least impact on the finish time. C has already got a float of 3. I want to move it by actual 5, so it starts here. So that will just delay the whole project by 2 days. Now we'll write that down, but we'll also show it on the diagram what that's going to look like. So by delaying C by 5 days, we can get it to move here. That has an impact on D, because D can't start until C is finished. So what will happen with D is D has a length of 4. It would actually end up going like this. So let's put the letter D in there. So then you can see that the finish time is now 2 days longer. So what we want to do is explain what we've done in words. So we want to move the peak, that's here, at C. We can do this by delaying C for 5 days. You can see it delayed for 5 days and starting here at day 11 from its early start time. Its early start time was 6. We're moving it to start at 11 rather than 6. Since it already has a float of 3, and we'll do the calculation to show its float is 3, 17 minus 8 minus 6, it will delay D by 2 days because D depends on C finishing. Hence, just add 2 days to the finish time, and you can see that here in the diagram. So ideally, we want to move the activities at the peak here, where the most workers are needed, beyond the 4 that we need. Maybe we could put a dotted line to show that here. And also look at their floats and pick the activities that have the largest floats, because they're the ones that will have the least impact on the time that we finish. You should now be able to complete exercise 8H on pages 247 to 249 of the textbook.